Welcome to the exam prep session on 7532, Developing Microsoft Azure Solutions. I'm Sydney Andrews. I'm a cloud applications consultant. I'm also the author and developer of a lot of training curriculum and material around Azure, including the 2532 Developing Microsoft Azure Solutions official course. I have a background in both Azure and XAML consulting. So today we want to help you out on the roadmap to Azure certification. This session is about 7532, the Developing Microsoft Azure Solutions exam, one of 3 exams necessary to earn the MCSD and Azure Solutions Architect. However, this exam will also earn you a specialist certification along the way, so you can earn something today for your effort today, while still working towards a goal for the future. So let's talk about the objectives for this session briefly. There are 5 main content areas in this exam. The first one is you're going to be designing and implementing websites. This is actually exactly how it's printed on the site. Even though the service is now called Web Apps, I did want to leave the original text here because this is how you're going to see it on Microsoft.com/learning. The second objective is to create and manage virtual machines. That's really just the beginning to IaaS and the beginning to infrastructure management. Then you have a cloud service management objective, a storage strategy, mostly focused around Azure storage and a little bit of SQL database. And finally, application network services, a catch-all objective for virtual network, service bus, and many other app services you may wish to use. To cover these objectives, what we're going to do is we're going to split this session into 5 main areas. We're going to start off by talking about web apps. We'll talk about virtual machines, cloud services, storage, and then virtual networks. There's a couple of takeaways from this session now, hopefully that you'll gain from sitting here with me today. For 7532, we hope that you get certified. We hope that you take this and you're able to go in and get certified either on your first attempt or using maybe shortly thereafter. But most importantly, even if you don't get certified, for this session, I want you to take away enough knowledge to feel confident developing Azure solutions and then go out there and get experience in developing these Azure solutions so that when it's time for you to get certified, you can combine what you learned here and your real world experience to have a much better chance of passing your certification on one of your very first attempts. Before we get started, a couple things I want to bring up. There are 2 portals for Azure: the current management portal, located at manage.windowsazure.com, and the preview portal, located at portal.azure.com. I'm going to use both portals in most of the slides. I'm going to talk about the different portals, and from time to time, I'll reference the difference between the 2 portals. But you do have to understand when studying for this exam that a lot of documentation you may read, a lot of samples you may see, presentations, they may use the preview portal, whereas you may be certified on the existing portal. And this vice versa. You could be learning something in the existing portal, and maybe you take an exam and see it with the preview portal. This is to say that you should definitely make sure you have experience with both portals. They're not too drastically different as far as what they do underneath the hood, but they do present different UI concepts. A little bit different as far as user experience. One is focused around services and service instances. The other one is focused around Azure Resource Manager and the resource model resource groups. So we'll use both portals throughout this session, and I just wanted to make you aware of that. Without further ado, let's get started. We're going to start by talking about web apps. With Azure Web Apps, this is the service that pretty much replaces websites. It's part of the Azure App Service. The Azure App Service isn't really called out too much in the exam objectives, so we're not going to spend a lot of time talking about that. But we are going to focus today on web apps, and that includes the deployment of web apps, configuring them, diagnostics, web jobs, scaling, and then we'll briefly mention a couple of notes around resilience. As far as deployment is concerned, one of the big things with web apps is flexibility in deployment. Now, flexibility from a developer point of view means you have a lot of options here. However, from a certification point of view, flexibility means there's a couple more things to make yourself familiar with. One of the big things you want to look out for is making sure you've, at least from a conceptual point of view, I recommend trying these 2, but at least from a conceptual point of view, understand the difference between the different deployment models. So if you're going to use web deploy for deployment, understanding what web deploy is, what the web deploy package format may be, the relationship between web deploy and IaaS, and how you can do deployments from Visual Studio to Azure, from IaaS to Azure, or with just a standard web deploy package that was created at the command line. So a deep understanding of what web deploy is, and not just, oh yeah, I right click in Visual Studio and it magically publishes my web app. That's really not enough to say you're certification ready. You really want to know what's going on underneath the hood. Luckily, the IaaS web deploy site does a great job of actually breaking down what is web deploy, what is going on underneath the hood, what do you need to know to use web deploy in your solutions. Another option that you want to look at is you want to look at continuous deployment. Now, we use VSO here as an example, Visual Studio Online, but you do want to look at least articles on how to do continuous deployment from other locations. I always recommend using one of your free projects within Visual Studio Online to actually go in, do a continuous deployment scenario, and just see how it works. You can do it with TFS source control, just so you can see how it works with TFS source control, or you can do it with Git. I also recommend setting up a free GitHub account and doing continuous deployment from GitHub. Understanding what's going on underneath the hood. For example, with VSO, how it's actually using a build definition to push to Azure, whereas with GitHub, it's actually hooking into the webhooks. So this kind of one's more passive and one's more active and one's more reactive. But understanding how continuous deployment works and how you can set it up can be the key to nailing any questions about continuous deployment in the exam. Another thing is you want to understand file deployment. Now, from the simplest point of view, we're talking FTP deployment. Deploying via FTP, the same way we did with our old front page or Dreamweaver web applications. Deploy via FTP, everybody's fine. However, you may want to use something like a site extension. The Visual Studio Online Monaco site extension allows you to upload files right into your root directory of your web application and work with them there. You can even set up a local Git repo, either using the web app by itself or using Visual Studio Online Monaco. The idea here is there's quite a few ways you can deploy to a web app. And you want to at least, if you have, I recommend trying all of them, at least having some hands-on experience with all of them. But at a minimum, you want to understand them at a conceptual level. Another big thing about web apps we want to talk about is configuration. And this is one that I find that a lot of people get confused about. And this is the purpose of the exam prep session, to kind of hit some of the high notes, things where people tend to get lost, get a little confused, things people don't really expect from reading exam objectives. And configuration is a big one. When you deploy a web app to Azure, you can deploy a web config. Let's just say we're doing an ASP.NET web app. You can deploy a web.config file. And this config file can have your configuration settings, maybe your SQL database connection string, maybe some application settings, maybe some connection strings to third-party data providers. There's a lot of different things you can have configuration-wise in your web config. But once you deploy this, you don't really have access to go and update your web config. Sure, you can use Visual Studio Online Monaco to go and change the web config around, but the idea here is that you want to actually release any of the settings that need to be changed after the deployment to something that's separate from your web app. And this is actually all handled in app service. With web apps, they have their own configuration store. And this is something a little, if you haven't used it before, it might be a little foreign to you. But if you go into a web app and you go and set up your settings and you create a configuration setting, at runtime, when your web application, whether it's .NET or any other framework, says, go get me configuration setting A, if you have a configuration setting set up in the portal or maybe using PowerShell at the web app level, it's going to override or intercept that request and provide your overridden application setting. So this can be done to have web applications use a different SQL database in production that the developers aren't aware of. This can be done to override web config settings. Maybe when the developers were testing the app, you want 3 items on the home page, but now you want 5. Understanding that this configuration can do an intercept request for web config, that's going to be an interesting thing, and that's going to be one of the things you want to know or at least try. This is one that at a conceptual level will be hard to see until you actually do a demo of it. So you actually want to go in and you want to try this in the portal. And as Azure.Microsoft.com has a really good tutorial on exactly how to do this. Another big thing with web apps I want to point out that you're going to want to try and put your hands on in order to be as successful as possible in this exam is diagnostics. Now, the big thing here is that you can go in, look at diagnostics logs in the portal. You can go look at them using the Kudu dashboard. You can even go look at them using Visual Studio. You can do a live stream of the logs. You can just look at logs at point in time. Logs can be stored in storage accounts. You have a lot of different options here, and from a diagnostics point of view. And that's not even mentioning the remote debugging options. That's just logs that I mentioned. So understanding the different ways that you can go in, look at your logs at runtime, look at your options at runtime, whether it's from Visual Studio or from the portal, that's going to be key here. So the big thing with diagnostics is just looking at your log information, whether it's in a storage account or you're looking at it live from the site. Let's briefly talk about Webshops. Webshops is called out in the objectives, so you definitely, if you haven't touched Webshops before, you want to touch them now. They don't cost anything extra on top of what you already have within your web app. So if you have a free web app deployed, you can definitely deploy a web job to it. If you have a standard web app deployed, it's not a new instance of a web app to deploy a web job. So understanding that billing implication is important. But the most important thing to understand about web jobs is what's going on behind the scenes. So with a web job, we basically have some type of application executable, whether it's the exe, sh, whether it's PowerShell, and we can run that executable. Now we can run it on demand. That means we go in the portal or use PowerShell or use some type of REST API to go in and say, run this job. That's on demand. We can run it in a scheduled fashion. Run this job every Tuesday at 5 p.m. Pacific time. That's a scheduled job. Or we have a continuous job where it's just running like a Windows service indefinitely in an infinite loop and is polling data. Maybe it's listening for requests, whether it's polling or receiving these requests. The idea here is that there's three really main ways to run a web job, and you want to be comfortable with all three of these ways and at least understand from a conceptual point of view what they do. The other big thing I want to bring up here is the Webshops SDK. The Webshops SDK is a .NET SDK, and it's really useful because it gives you method parameter attributes where you can basically say, go in here and this method will handle the event that a queue, or excuse me, not method parameter attributes, method attributes. This method will handle the event that a queue receives a new message, or maybe a storage container has a new blob, or maybe a table has a new record. And if that scenario occurs, call this method. So it allows you to actually build some really interesting scenarios, maybe implement something like the competing consumers pattern without having to go in and write the individual logic to go check the queue, check the storage container, check the table. It's all built into the SDK. So you can literally just say attribute, whenever this queue receives a new message, call this method, and that's it. So the Webshops SDK is a critical part of using web jobs. You can still create web jobs without the SDK, but you're definitely going to want to know how to use the SDK. Continuing on web apps, one of the other things we wanted to talk about here is scaling and hosting. So one of the big things with web apps is that we have an app service plan, and this app service plan can contain as many web app instances as you want, up to whatever billing or pricing tier you have. So whether or not this app service plan contains 1, 0, 50, that's really all up to your billing tier. Standard tier supports a certain limited threshold. The premium tier supports up to a certain amount. The shared tier supports up to a certain amount. Everybody pretty much has a clear understanding how app service plans work, and these were formerly referred to as web hosting plans. But when you get into the resource group model, this gets a little fuzzy. So the idea here, and this is to help you out with this, is that a resource group can contain 0 to many app service plans. So the big thing you want to focus on in this diagram is that this resource group can contain 0 to many app service plans. The app service plans can contain 0 to many web apps, API apps, mobile apps, or logic apps. The thresholds or limits are based upon billing, not a technical threshold. So if you pay for a tier that supports up to 10 instances or pay for a tier that supports up to 50 instances, that's your threshold. The other important thing to remember here is that app service plan can have 2 web apps within it, but if these 2 web apps are in the same app service plan, they can't live in other resource groups. The hierarchy goes resource group, app service plan, app instance, whether that's web, logic, mobile, or API. One of the things I wanted to talk about is deploying web apps. Now, when we talk about deploying web apps earlier, we talked about you can use FTP, you can use continuous integration, you can use web deploy. I wanted to come back to this because in the new portal, the UI has changed a little bit on how you do deployment. Now, I'm referring back to what we talked about earlier. You can still do web deploy. You can still use FTP. You can still do continuous delivery. All of this is supported in the new portal. But the new portal exposes a feature, and it was available in the older portal, but I think it's a lot more visible here in the new portal, called deployment slots. It changes things up a little bit when you talk about deployment. The big thing for deployment slots is that you acquire standard premium app service plan, but a deployment slot creates a new instance of your web app. Now, if you have a web app and it's your production site, let's say it's your e-commerce production site, you can create a testing deployment slot, a QA deployment slot, maybe multiple dev deployment slots. And these deployment slots basically function as a web app. You can clone configuration from the initial web app in the portal, in your UI, whether it's Visual Studio, old portal, new portal. They all will be shown together, but functionally they are basically separate web apps. So deployment slots give you a really clean and neat way of creating new separate web apps that can be used to deploy different versions of your web application. But the magic in deployment slots come into swapping slots. So for example, let's say I have a production web application and I have a test web application. My project managers, maybe my stakeholders, they test the test web application and say, you know what, this is perfectly fine and we're ready to go to production. So I can actually swap production and testing. So old production is now in the testing slot, and what was old testing is now in the production slot. And that's great. So now the new version of the application is live. A lot of people seem to understand that concept. So that one, that's, if you haven't used deployment slots before and swapped the different slots, you're going to want to try that out. The really sticky thing, and I use sticky purposefully here, is sticky slot settings. Now let's say we have our production instance and our test instance, and we want to swap them. Well, what if we have a production database and we don't want that production database pointing to test and we don't want the test database pointing to production? What do we do? Well, earlier I mentioned application settings and how they can override settings in your application. One of the big things with web apps is when you can create a setting and say this is a slot setting. So in the production slot, I can say creating a setting with a SQL database connection string called production database. And now when I swap slots, that setting stays in a production slot. No matter how many swaps I do or how many web application instances, I can actually swap the web application binaries and other settings, portable settings I like to call them, but slot settings remain sticky. They stay with the slot no matter how many swaps you do. So it's a little tricky if you haven't ever done swapping of slots before, but you definitely want to go in and see that setting. You'll see it in the portal. When you go look at a configuration setting, it'll have a checkbox next to it say slot setting. And that's where we talk about swapping slots. I've talked about app service plans, but I did want to just mention them one more time. App service plans really serve as a container and unit of billing for your app service instances, whether it's web app, mobile app, logic app, or API app. Web apps is the focus of a lot of this developer exam and definitely the focus of this objective. But there are other types of apps you can deploy, specifically logic and API, that did not exist at the time that the objectives were written. We did talk about the relationship between resource groups and app service plans, but I did want to point out one other thing. A resource group lives within a data center region. So once you create a resource group, your app service plan lives within that resource group. Web apps live within that app service plan. So you create a pretty clear hierarchy. So for example, you can have multiple resources in a resource group, but they all must be in the same subscription. So you can't have two web apps, one in one subscription, one in the other, but still be in the same resource group. There's a very clear hierarchy here. Subscription, data center, resource group, app service plan, app instance. And that's just something you want to keep in mind. So let's look at a sample question. Questions are broken up into 3 parts, and as we look at sample questions, I will show you each of these individual parts. So for this first sample question, we're going to start off with our context. You are a consultant for Fabricum.net. Once we state the context, and the context can be as short as that or it can be pretty long, we will come up with a business problem. So your client is interested in deploying a public-facing web application using Azure Web Apps. The web application uses a third-party API, and that requires a secret key or a credential. So whenever you make a request to that API, you must send the key with that request. Fabricum will like to store the credential, but they do not want to expose that credential to the application developers. So now we've stated the business problem. Once we do that, we propose a goal. So how could Fabricum store this credential? And usually when you see a certification exam question, they give you very clear instructions on what to do. So to answer, select the appropriate option from the available choices. So we have a couple choices here, but our solution would be to add the credentials to the application settings in the Azure portal. That way, we have these credentials in the application settings for the web app, but we don't have to actually give the key to the developers. The developers can use a development key or a test key, or maybe they can test against a proxy or maybe just some type of demo or test API. We can have the key to the real API and not expose that to everybody in the company or expose it in plain text to the developers of the company. Just put it at the app service level. So now that we talked about web apps, let's talk about virtual machines. Virtual machines, even though you're a developer, are a key important part of this exam because one of the interesting things about Azure is that you kind of blend what you're doing. So for example, I commonly talk to people and train people on 533 exam, which is the infrastructure or IT pro exam. And a lot of times they say, well, there's a lot of stuff around cloud service and web apps, and I'm not a developer. And there's a lot of PowerShell, and I do a little bit of PowerShell, but this is really tough. And I like to, I'm not a developer. I'm not writing this much code. And so they have the same concepts and they have the same concerns. Well, hey, I'm doing a little bit too much developer stuff. And then when I talk to developers around 532, it's, oh, virtual machines, I'm not an infrastructure person. I don't do virtual machines. I don't do IaaS. Why do I have to learn about virtual machines? Well, as a developer, you do have to actually deploy virtual machines. You want to be able to create dev test environments. You want to know enough about virtual machines to be able to stand up your environments. That's like saying as a developer, you don't have to know your operating system because you have to know your operating system enough to configure your dev environment. The same thing is true in Azure. You have to know virtual machines enough to be able to effectively configure a development environment, but more importantly, to be able to prescribe infrastructure to your operations team, your IT pro team. It's not useful to hand them off an application and say, go, make this work. Sometimes you want to be able to come back to them with recommendations. Well, this can only work in cloud services, or this can only work in VMs, or this can only work in web apps based upon requirements within your application. And if you don't know how cloud services work, if you don't know how virtual machines work, if you don't know how web apps work, then you're going to have a hard time making these distinctions. And that's why it's important to actually cover virtual machines and cloud services. So when I go through this section, I'm not going to spend as much time on virtual machines because your depth of knowledge doesn't have to be as deep as the IT pros. But you do have to have a depth of knowledge to be effective using virtual machines in Azure. To get started, one of the big things you want to be able to do with virtual machines is to be able to deploy a workload on VMs. You're going to want to know a little bit about virtual machine images. You're going to want to know how you do configuration management with virtual machines, networking with virtual machines, scaling, storage, and then eventually management of those virtual machines. We're going to cover some of the key points here as, again, exam prep is meant to be very brief. So let's start with deployment. So there's so many different ways you can deploy virtual machines. And at the end of the day, all of the ways you deploy virtual machines is the same way. So at the end of the day, the Service Management REST API or the Azure Resource Manager REST API is how everything gets deployed. Whether you're using Portal, whether you're using PowerShell, whether you're using Visual Studio, whether you're using a third-party tool, at the end of the day, they all use a REST API. And as a developer, if you want to use the REST API, you're free to. So when you deploy a virtual machine, and we're talking about legacy version 1 virtual machines here, there are V2 virtual machines now, but the exam objectives are really focused on the what we call the classic virtual machines, and that's the one you're going to want to know. When you deploy them, you're doing a couple things. First off, you're having a virtual network, and within that virtual network, you place a cloud service. Within the cloud service, you can place 0 to many virtual machines. A virtual machine can be combined with storage. So a virtual machine is really the reservation of compute, some memory, some CPU time. You have to have a disk. So you have to use a storage account. Your storage account can contain images, they contain disks, whether it's an OS disk or whether it's data disk. Obviously, the OS disk is required. The data disk is really up to you how many you need. You can use an image from your storage account. If you're deploying a template for an Azure portal, it's using an image from another storage account. So it's really the combination of a storage account, virtual network, virtual machine, cloud service that really composes a virtual machine. The cloud service and the virtual machine compute instance is the reservation of compute and a reservation of a virtual IP address. The storage account is the actual storage of the disk. So these are important concepts to remember, because if you try to destruct a virtual machine or delete a virtual machine, you have to remember that there's artifacts all over the place with this virtual machine. There are ways to handle that we'll get to a little bit later. From a deployment point of view, there's quite a few ways you can do deployment. You can deploy using an image in the marketplace. And really, at the end of the day, all this is doing is that there's an image stored somewhere on Azure by somebody else. And you're just copying that image to your account as a disk. That's it. I wish I could say it was a lot more complicated than that, but that's really what's going on. And you can create that using the marketplace, or you can just go into PowerShell and create your VM there. You can create a VM using Visual Studio if you like. If you really want to get into it, the big thing is that Azure Resource Manager kind of makes this a little bit easier. So we're going to look at deployment using Azure Resource Manager. Now, Azure Resource Manager introduces a new model of deployment. There's VM creation, whether you're using a template or using Wizard. You can still use PowerShell to create your VMs, but I'm going to let you in on a key hint here. Underneath the hood, all of these VMs are still created using a template. So essentially, Azure Resource Manager introduces this concept of a JSON template. As a developer audience, I'm sure you've probably seen JSON before. But the idea here is in this JSON template, you define resources and relationships between resources. If you use an ARM for VM creation, you can create V1 or classic VMs in ARM, or V2. If you create classic VMs in ARM, you're really creating a cloud service, a virtual machine. You're either creating or using an existing virtual network. You're creating or using an existing storage account. You're creating a disk and a container in that account. The idea here is that you can draw up this template yourself, and you can use the portal to test this template out, or you can use Visual Studio. It has an ARM template, a project type. Or you can go to the portal and use the wizard to create a VM. If you use the wizard to create a VM, behind the scenes, they're just generating a template for you and then deploying a VM using that template. So you're essentially just filling out parameters for a template if you use the wizard. You can forego that and do this all yourself if you like. Again, this could be used with classic VMs, or it can be used with the new version 2 VMs. The idea here is that there's quite a few different ways you can deploy VMs, and you want to focus on the classic ways when you're studying for the certification exam, but you don't want to ignore ARM. The big reason you don't want to ignore ARM is because you're deploying a template into a resource group. So you're deploying all of the related resources for a VM into a resource group. Now, if you need to remove that VM, you don't have to worry about artifacts. All you have to do is just go delete the resource group, and all your artifacts will be removed as part of that delete action. So that just provides a different way to think about how we're creating this infrastructure. When you do create the virtual machine, whether you're creating it with PowerShell or if you're creating it with ARM, one of the things you can do is you can actually configure the virtual machine as part of the creation step. Yes, you can create a VM, RDP into it, and configure it, but we kind of live in this modern world where we want to automate configuration management, whether we're using Chef, Puppet, whether we're using some type of other technology. We want to configure our virtual machines in a declarative way. Well, desired state configuration allows us to do this using PowerShell. So in this example, DSC configuration, we're essentially just taking a machine, enabling IIS, and installing ASP.NET 4.5. That's it. So we can take this DSC configuration script and apply it to 5 or 6 VMs. We can do that after the VMs are created, RDP in, and apply the configuration. Or if we're using ARM, we could include this DSC script as part of the ARM template. If we're using the classic VM model, we can install the VM agent, a custom script extension, and apply this DSC configuration. The idea here is that DSC allows us to automate the configuration of our VM. And you can do some really fun things with DSC. I've actually gone as far as installing Visual Studio, installing the Azure SDK, installing Azure PowerShell, and all of that, all in DSC script, so that I can create a VM with everything I want configured all in one click. That's the power behind desired state configuration. And you definitely want to know about it as a developer when you're thinking about creating your development environments. I did mention a VM agent briefly, and I wanted to stop to talk about it because it's called out exam objectives. But as a developer, you might have just, and I know IT pros who do this too, you might have just skipped this step in the configuration and not really realized what was going on. The VM agent is just what it says it is. It's an agent on your virtual machine, and it will receive a request to install extensions. So when you install the VM agent on your virtual machine, you'll know because the very first extension installs is the BG Info extension. This is why when you RDP into a virtual machine or classic virtual machine in Azure, you see information, disk size, all of this, the BG Info, background show up. That's because we're installing it using a VM agent. The VM agent allows you in an asynchronous manner to install extensions to your virtual machine. So you can install extensions, ones you wrote, ones you bring in for the community. There's extensions to do all sorts of things, but it just gives you a way to customize your VM again in an automated manner without having to go in and manually RDP and install things on your VM. One other thing I wanted to call out, I've seen that a lot of people seem to understand that concept of endpoints with VMs. If you want to connect to a virtual machine, you have an endpoint. Let's say you have a port 80 endpoint and then to a web server, or you have an endpoint for RDP. That concept seems to be a little bit easier to understand. Everybody gets that. But then you always get the question, with these classic VMs, how do we lock them down? What if we only want people from a certain subnet to be able to access RDP? Well, you can do this with access control lists. Access control list is a feature you've been using without realizing this whole time. When you create a new endpoint for your virtual machine, the access control list by default just whitelists everything. Now, the big thing here is for the access control list, we can go in and set up what subnets we want to allow and deny access. So maybe we're going to permit access to a subnet at a certain company, but deny access to all other subnets. The idea here with the access control list is we can customize the level of access based upon the IP address and an action, permit, deny based upon the IP address, or not IP address, subnet range. And then we can only allow certain IP addresses to access this endpoint. Again, another level of customization. The exam objectives do call out access control lists, and that's how we do it with classic virtual machines. If you're interested in how we do this with V2 virtual machines, we do that using network security groups. And that's something that, that you can go into a little bit deeper if you want. Network security groups is a little bit more on the IT pro side. So I wouldn't, as a developer, say you need to know network security groups to pass this exam. Let's look at another sample question. So we're going to start with our context. You're an infrastructure architect for humongous insurance. Then we go into our business problem. You're creating VMs in Azure to support a project that your company has outsourced to a third party. You need to create a VM endpoint for RDP that can only be accessed by a specific subnet at the third party's corporate facility. Once we get past the business problem, we'll hit the goal statement. Which virtual machine feature could you use? To answer, select the appropriate option in the answer area. Now, this one shouldn't be too difficult because that's literally the last thing we talked about. You would use an access control list. Now that we talked about virtual machines, let's look at cloud services for a bit. We know cloud services right now as a container for virtual machines, but they can do so much more. And as a developer, you can leverage them for so many features in the PaaS model or platform as a service model, where you do some configuration, some management, but a lot of the heavy lifting, a lot of hard work is managed by the Azure infrastructure. So there's four main topics here when we talk about cloud services. We're going to talk about design, configuration, deployment, and then eventually monitoring. So let's talk about designing cloud services. A cloud service really is a container and a virtual IP address. So the cloud service has an IP address that the world can access the cloud service to. It might be there might be a certain IP address, and then whenever you want people to access your web application, they can use the IP address, or you can do something with your domain provider or domain host. The idea here is that this cloud service serves as both a security and access boundary for anything within it. Now within this cloud service, we can have web roles or worker roles. We can also have virtual machines, but for the sake of cloud services, we're going to focus on web roles and worker roles right now. Web roles are exactly what you think they are. They're just compute instances that host a web application. Worker roles are compute instances that don't host a web application. By default, they're implemented certain ways to kind of drive you towards patterns, but if you're studious enough and you pay attention, web roles and worker roles, the only difference is that the web roles has the IIS, the mandatory minimum for IIS hosting core installed. That's it. If you want to host a web application in a worker role, you could. Just open up port 80 and self-host in memory. The templates you get is the ASP.NET application, a web role, and then on the worker role side is just a service, a console application that loops indefinitely. But these are just templates. At the end of the day, they could be implemented as whatever you want. But for the sake of studying for the exam and understanding how they work, you're going to want to separate things into web roles and worker roles. The other side of that is by me explaining to you how they work underneath the hood, you know a little bit about the boundaries of what you can and cannot do. One of the things I want to point out in this diagram is that you deploy things to cloud services using cloud service packages. You can deploy the cloud service package manually using a portal. You can deploy the cloud service package using PowerShell, or you can deploy the cloud service package using Visual Studio. But all of these mechanisms are just deploying a cloud service package. What is a cloud service package? It's just a definition in a compressed folder and binaries in that compressed folder. And outside of that compressed folder, a configuration file. Now, the configuration file is separate from the application binaries so that you can change the configuration as you deploy. Maybe a developer will build an application. It's a web application, and the developer only has access to the SQL database on-prem. So they have the SQL database connection string for the on-prem SQL database. However, the IT pro or the operations manager who's deploying this application, they're the ones who have access to the SQL database, maybe hosted in Azure or hosted in a co-located facility. So they'll take the configuration file and just put it in a new configuration string, or not configuration string, connection string. They put it in a new connection string, that's it. So this configuration file offers them flexibility without having to reveal secrets about the organization to every developer just to make deployment work. Now, from a configuration point of view, a configuration file is pretty simple to understand. It defines your bindings for your roles, so endpoints, defines certificates, and this is actually, this would be the CSDef file. So this is the service definition. What it does is it defines the web roles. When you define the web roles, you define endpoints. So here, this web role has port 80 endpoint and defines a certificate. So we actually have a certificate here, but you didn't necessarily have to have a certificate to use this web role. Maybe you're just using HTTP protocol instead of HTTPS. The big takeaway here is that this service definition file is part of the configuration for your cloud service, but it's stored within the cloud service package zip file. This is on purpose. When you deploy the cloud service, the service definition file, it needs to be exactly matching what's in the binaries. So this is something that your operations team will not be changing. This is not something you change after the fact, after deployment. This is something that you need to design your whole service around. So this is actually put inside a zip file. It's actually made inaccessible on purpose so you don't accidentally change it. However, the cloud service configuration file, this one provides settings, things that can be changed at runtime without breaking the application. Obviously, if you change how many roles there are, maybe it's 3 web roles now instead of 2 web roles and a worker role, that would break the application. But if you change something like a connection string or you change something like an application setting, that's not going to break the application. So things that need to stay put are really put in the service definition file. Things that can change are really put in a cloud service configuration file, or CSconfig. Now that we talked about the packaging format, one of the big things as developers, Visual Studio makes cloud service deployment too easy. You don't really see what's going on underneath the hood, and that's something that we're really covering here in this session. So as far as deployment, you can actually deploy, again, using whatever format you want. The big idea here is that you can deploy to a staging or production site slot in your cloud service. Now, this is very similar to what we talked about with web apps. The only difference is you can't create unlimited slots. It's staging, production, that's it. Now, normally what you see is people deploy to the staging slot. Then when they're ready to send this application to production, they swap to the production slot. So whatever is in production goes to staging, whatever's in staging goes to production. While you have both slots active, you are accruing basically twice the billing. So if you have a single web role with two small A0 VM instances, if you have staging and production active, you now have 4 instances. So there's a billing implication here. So the idea here is that we usually swap and then we check production. We say, is the application working as expected? You probably heard of this as like settling your application, post-production release. Once we can confirm that application is working as expected, we tend to archive what's in staging now and say that was production as of X date, and then get it away from here. Because we don't want to pay double billing for too long. You only want to pay for it when you absolutely must, and that's during the actual production rollout, during the actual settling. One other thing I want to bring out about deployment. When you deploy, you can continuously deploy. And if you continuously deploy, and we're showing all this in the old portal, but if you continuously deploy, you can actually manage active deployments for your cloud service. So this continuous integration model is pretty useful. And it's very similar to what we talked about with web apps. In this point, you don't even get into the business of managing the packages at all. You're just completely washing hands clean of all of that. However, if you are deploying from Visual Studio, then we can do it 2 ways. We can deploy the whole cloud service package. That's pretty simple. We just go in, right-click, publish, and it'll create a cloud service package and deploy it using the REST API to Azure, and it'll actually do the standard deployment. Now, the downside to that is the cloud service deployment takes a little while. People say it's slow. The reason it's slow is because it's actually creating VM instances. Every web role, worker role instance, and this is something I can assume you know, but they're virtual machine instances. We're covering the harder things about this exam. We're not covering like maybe the obvious things, but what's not obvious is that whenever you do a new deployment, you're basically creating new VMs. So that's why it takes so long. Then it's getting faster because VM creation is getting faster. But it's never going to be as fast as a web app instance or anything like that, because those are pre-configured, especially if you're using shared or free hosting. You're just using a slot in some IIS install. So this is actually designed for fast deployment. Whereas cloud service is creating your VM instances anew whenever you're doing deployment. However, you can speed up deployment. You can use web deploy. So when you deploy your cloud service package, there's a configuration setting, especially use Visual Studio. This is actually surfaced, really easy to do, to enable remote desktop access and web deploy access. Now, yes, you can actually RDP into your cloud service web role, worker role instances. There's no reason you ever want to do this, but it's there if you want to do it. And it's really useful because if you enable web deploy for that role, you can actually go and remotely deploy using web deploy as opposed to the cloud service deploy. And that's much faster because you're just deploying to IIS from Visual Studio. You're not creating new VM instances. It's not the preferred method of deployment, but it's definitely an option there. So we're going to look at another sample question. In this sample, the context is that you're an administrator for AdventureWorks. Your business problem is that you received the cloud service package. It's a compressed file from your development team. You're now tasked with deploying this package to Azure. They also gave you a cloud service configuration file that you can change to. Which two of these options are going to allow you to deploy this cloud service package to Azure? So are you going to use the Web Apps Migration Assistant, Web Deploy, Continuous Integration with GitHub, or the Azure Migration Accelerator? Now, continuous integration with GitHub is one of the ways you can deploy to Azure. You can deploy with Web Deploy. Each of these options will require you to actually go back to the development team and have them show you using Visual Studio how to set up continuous integration or maybe how to set up Web Deploy deployment. Now, the cloud service package part of this problem wasn't really useful information. It was there, but you don't really need the cloud service package. You can actually deploy this all directly. If you wanted to use the cloud service package to deploy, you would use something like PowerShell, or you could use the portal directly. If you want to deploy directly from the ASP.NET web application in Visual Studio, you can use Web Deploy. If you want to deploy directly from a source control repo, you will have them commit their code to GitHub. And all of these options will actually create your, especially the continuous integration with GitHub, will create your package for you. Web deploy is the only one that won't create a cloud service package for you. It's because it's deploying to the IIS instance directly on that virtual machine. Now that we talked about a lot of our copy instances, let's get into some of our other options. The main one we're going to want to start by talking about is storage. And then once we covered storage, we're going to go a little bit into some of the other services around networking and app services available to us in Azure. For storage, the main things you're going to want to think about is blobs, tables, queues, and files. These are the 4 primary storage services, and we'll talk about them briefly. And then we'll also talk about access control with storage. And then we will briefly mention SQLDB. It seems that SQLDB is not the one a lot of people need a lot of exam prep help on, but I'll briefly mention it. Blobs, tables, and queues seem to be the most foreign, and the one where we spend the most of the time talking about it. So let's talk about storage blobs and storage files. Storage blobs are blobs. They're files stored in a hierarchical manner in a storage account. So a storage account can contain 0 to many containers, and a container can contain 0 to many blobs. You can emulate a file structure using the namings or the names for blobs so that you can have something that looks like a folder structure, but essentially all blobs go in the root of the container. So it's pretty simple to understand how blobs work. Now, you can make a container publicly accessible so that any anonymous request at a container will return a blob. And all containers and blobs have a URI. So it's going to be storage blob windows.net /name container /name of the blob. The big thing here is that it's really simple to use. It's one of the things with blobs is that if you've never used it before, it seems daunting. Once you use it, you realize it's really out of the way. There's no reason to ever bring in an SDK or bring in a third-party API to work with blobs when you can just construct the URIs or URLs just from basic logic. The other big thing about blobs is that if you can lock down the containers, that's where it gets really interesting. A lot of samples you see people have anonymous containers, but once you start locking down containers, that's where things get interesting. So you can lock down a container so that people, one of the lightest ways you can lock down containers is that people can't browse the list of blobs. So by default, people, if you turn off any type of security, you just say, hey, you can access anything at the container level. People can see information about the container. They can list all the blobs in the container, or they can download an individual blob. You can also set it up so that people can access a blob only if they know the exact URI for that blob. It's still publicly and anonymously accessible, but it requires you to know the exact URI of the blob. You can't mine this information based upon looking at the container. And of course, you could cut off all public anonymous access. This is where things get interesting because you can start issuing SAS tokens. So you can issue a SAS token to temporarily access a blob. There are 2 types of blobs you want to be aware of, a block blob and a page blob. They're both used for different purposes, but the easiest way to remember is a page blob. It's like pages on a disk, used for VHDs. Block blob tend to be used for multimedia. That's the general assumption around them. There are some exceptions. There's some minute details. But that's usually the easiest way to remember. Now, the other service I want to talk about here on the side is the Azure File Service. The Azure File Service provides a REST API to files within a storage account. Now, these files are exposed as an SMB 2.1 file share. So you can mount this file share inside of Azure Virtual Machine. Now, the exam talks about the SMB protocol and objectives, and it says, yeah, Azure Files know what it is. However, Azure Files just went GA not too long ago, and more features have been announced, specifically mounting these shares in your local machine. These are more recent announcements, and you can always, the more recent announcement, the less likely to be on the exam, as it takes a while to generate questions and things like that. However, that's something you do want to be aware of, that's functionality is here. However, most people are using Azure Files to mount SMB file shares in a virtual machine to emulate existing file shares for the application. Maybe the application depends on SMB file share on premise, and they need that to lift and shift this application to Azure. Azure Files is pretty attractive because it could just emulate that without them having to change the code for the existing application. One of the things I wanted to talk to you about is tables. Now, tables is really focused around this whole concept of NoSQL storage, and tables allows you to store entities that do not have to match a specific schema. So the hierarchy here is pretty simple. You have an account can have 0 to many storage tables, and a table can have 0 to many entities. Now these entities don't have to conform to a schema. So you have one entity with properties such as first name, last name, and age. And another entity with properties such as grade level, teacher, and maybe health notes. The idea here is that you can put whatever entities you want in here. You just put them in as JSON, and that's it. That's the thing about storage tables. You can store documents, or it's not really a document storage, NoSQL store. It's more of a key value type NoSQL store, but you can store entities, and these entities are made up of properties, and these properties are really just key value pairs. So if you used to work in a dictionary, just think of an entity as a dictionary, and you'd be good to go right there. Now, I'm not going to spend a lot of time on storage tables because a lot of people are using DocumentDB as alternative storage tables. But if you haven't worked with a key value store, you want to take some time to actually go and play around with storage tables. It's actually pretty easy to use it. There's a storage table explorer in Visual Studio where you can actually generate OData queries and use these OData queries to query entities. The big key points with storage tables you want to remember is that just like Blobs, you can generate SAS tokens to access storage entities so that people who don't have access to the table can be granted temporary access, just like with Blobs. And the other key thing to remember with storage tables is that they have a very strictly defined partitioning scheme. So when you create a storage table entity, you're required to provide a certain amount of properties or key value pairs. One of them is the row key, and the other is partition key. The partition key basically defines what records should live close together, because Azure is going to automatically partition this storage table across multiple instances across geography. So you might have some records being table in one data center, some records being table in another machine in that data center. The idea here is that if you define a partition key, it's going to try and keep any records with the same partition key as close together as possible. So this partition key is a way to say these records related, keep them close together. The row key is just a key that needs to be unique within a partition key. So if you have a partition key of students, and if you have a row key of, let's say, a student called Alex, then you can't have another row key of student called Alex within your partition of students. If you have a partition of teachers, you can reuse the same row key all you want. You just can't use the same row key multiple times within the same partition. That's the only thing you're really going to have to think about with storage tables. Queues is a little bit simpler concept to understand. It's based upon a computer science queue. So if you have a computer science education, you've probably heard of queues ad nauseum. But if you don't, a queue just allows you to send in messages, typically in a first in, first out manner. There are some exclusions with storage queues. The idea here is just like Blobs, there's a hierarchy. So an account can have 0 to many queues. A queue can have 0 to many messages. With storage queues, you can generate a SAS token so that somebody can have temporary access to the queue or message on the queue. That's really it. Storage queues are unique from service bus queues. That could be a whole hour-long session by itself. For your point of view, there's an MSDN article that's really great about this that actually compares storage queues and service bus queues. For your information, the biggest thing you want to remember about storage queues is that a storage queue doesn't guarantee order. It doesn't guarantee that you'll see a message only once. Whereas the service bus queue can optionally guarantee order or guarantee you only see a message once. Both queues guarantee that you'll at least see a message once. Storage queues, the way they work is that you don't delete a message or pop the message from the queue. What you do is you make the message invisible to other queue consumers while you try to process it. Why is that important? So let's say we have a cloud service and a worker role, and we want to process queue messages. And we have an image processing library, and we're creating images, ping images, maybe thumbnails, whatever. And we get a message off the queue, and our application crashes the whole virtual machine. Well, cloud services can determine if something went wrong and create a new VM instance. It's pretty much self-healing. However, our queue doesn't know that. So this is why we make the queue message invisible instead of deleting it. Essentially, when we finish processing the message, we'll delete it. But when we first get the message, the only thing we're doing is saying this message is invisible to other queue consumers for X amount of time. Let's just say 30 seconds. If after 30 seconds we haven't went back and said, queue, delete this message, then now the message is available for somebody else to process. This is really important as an application developer to understand, because you as an application developer, when you're using a storage queue, you need to design your algorithm to treat messages to the same whether you process it 1 time or 15 times. So if you don't have logic in your application to say, hey, I seen the same message, either reprocess it or just do something different, then you're going to get lots of repeats and you're going to see a lot of issues across the board. So just remember that with storage queues, you're not deleting messages from the queue until after you finish processing them. So you do have the possibility of processing a message more than once. That's the real unique thing about storage queues you want to remember. Let's talk about access control. We briefly touched on this with storage accounts, but I definitely want to go into this a little bit more. Your application can access queues, tables, blobs, files in a storage account. Essentially what we do is we go and we request a SAS token. So application says, hey, this user wants to access this Word document stored in the docs container called agenda.docx. So it goes get a SAS token and says, you have access to agenda.docx for the next 5 minutes and you only have read access for it. And returns this SAS token to our application. Once this token is returned, we're going to make a storage request with that SAS token. Now the application can make that request, or we can just give the user the URL and apply that SAS token to the end of the URL. And they can make the request. Let them do the work. I don't want to do the work. My server doesn't want to do the work. Let the user do the work. So we give them the SAS token, they append it to the end of the URL. They go to the storage account themselves because that's all it's doing when they pop that URL into a browser, or maybe they have a mobile application that says go download this from the URL. And it can get it without our application being involved. Once the storage account receives that SAS token and validates it, it responds with the content. So this is essentially it. This is how access control works in storage accounts. It's not really hard to gather. Wherever you want your application to use the SAS tokens to access information, or you want to give these SAS tokens to users, you can. As a recommendation, if you want to see a really good pattern for using SAS tokens in storage and actual code samples, there's a pattern called the valet key pattern in MSDN, and that pattern will be a great way to actually see a really big demo of how all of this works. But at the end of the day, what you really need to know to excel at this exam is that there is access control methodology and applies across the board, whether it's a blob, queue, table, files, and the actual implementation doesn't change no matter what type of storage instance or storage account instance it is. Let's briefly talk about SQL database. I did promise we'll cover this a little bit, but essentially SQL database is just managed SQL as a service. And I think the purpose of the exam prep is not to just say, hey, here's what SQL database is, good luck, is to call out things that you need to be aware of to excel at this exam. And one of the things I want to call out with SQL databases is that you have tiers. And these tiers give you different features. And they're designed for different type of applications. So for example, if you have a single application that's, small database, you don't expect transactions, or a lot of people hit in database, you're using this for dev test, you can go with the basic tier. The majority of cloud applications are going to go with the standard tier. While the basic tier can do transactions and things like that, there's a much smaller threshold of users you can theoretically handle, much smaller level of requests you can handle, whereas the level of service is much higher for standard. There is a premium tier if you just have a high volume transactions. It's just you have a crazy volume of transactions. You can't even touch the standard tier because you're nowhere near what normal applications are. You have a very specific niche and you need to make sure that your application's transaction volume is supported. Then you go to the premium tier. So that's the easiest way to remember. Basic is good for dev tests. Standard is good for the majority of applications. You'll know if you need premium long before you even consider Azure SQL Database. That's the easiest way to remember. As far as performance, we measure performance using this thing called DTUs, or database threshold units. Now, DTUs are interesting because they're not any unit you've seen before. They're a combination of other metrics of the database, and they're presented in a way to allow you to relatively compare tiers. So here's the way to think of DTUs. A DTU is a relative comparison. So the basic tier is 5 DTUs, whereas the standard S0 tier is 10 DTUs. That means you should expect twice the performance for the standard S0 tier than the basic tier. Same thing goes the other way. If you go to the premium P1 tier over the standard S0 tier, that's 100 DTUs versus 10 DTUs. You should expect 10 times the performance on the premium P1 tier as compared to the standard S0 tier. So let's look at a sample question. So we're talking about storage, and so our context is we're a developer for Contessa.com. We need to create a new instance of the Cloud Blob client class in .NET because we would like to create a container and we like to create blobs within our Azure subscription. So how do we use the Azure Storage SDK to create this? So which options should we select? Now, you will, in certification exams, see different innovative types of questions. Some of them may require you to use a drop-down to fill in code. You may drag and drop. There's so many different types of innovative questions that are featured and discussed on Born to Learn. And in this sample, we would fill in the blanks for our code. So we use a Cloud Configuration Manager.getSettings static method on that class to get the connection string from our cloud service configuration. Then we're going to use the parse method of cloud storage account. Again, that's a static method to use our connection string to get a cloud storage account instance. And then once we have the cloud storage account instance, we can call the create cloud blob client method to create our cloud blob client. So just knowing the SDK would be useful. But the great thing about the storage SDK is that this sample can be used for blobs, can be used for tables, can be used for queues, and can be used for files. No matter what type of storage account, whatever you're doing with your storage account, a lot of the underlying things are the same. So if I wanted to use tables instead of calling create cloud blob client, we would call create cloud table client. That's it. That's the big difference between the tiers. For the last section of this exam prep, we're going to cover some of the things you need to know about networks to be successful in this exam. First, we're going to talk about networking management from point of view of Azure AD, virtual networks, a little bit of virtual networks config, and then these are other topic areas that we have included in this deck as additional hidden slides. So when you download this deck, you're actually going to get an additional 15 to 20 slides that covers a little bit deeper on networking management that weren't excluded, but just weren't made into the cut of this video. So the great thing is this deck has even more stuff than we cover in this video. So let's talk about Azure Active Directory briefly. Now, Azure Active Directory allows you to extend your identity to the cloud. This is really important. As developers, we don't usually touch AD unless we're doing some LDAP queries or we're integrating with some existing application that handles the AD integration for us. Now, Azure Active Directory, and I'm going to say this really clear, is not Active Directory in the cloud. Azure Active Directory handles the identity objects from your directory, and that's it. So if somebody syncs identity from Active Directory to Azure Active Directory, they're just syncing that identity. So group policy, a lot of other things that stored in Azure Active Directory, a lot of other things stored in traditional on-premise Active Directory is not synced up to Azure. If you need those things in the cloud, you would actually bring an AD box into Azure in a VM in a virtual network. Azure Active Directory is just an identity provider. So what is an identity provider and why it's useful? If you've ever integrated an identity provider application, you probably integrated Facebook. You probably integrated Google. You probably integrated Twitter. You might have even integrated a Microsoft account. Those identity providers, they authenticate the user for you and let you know that, hey, this user is authenticated and here's some claims about them. You trust the identity provider to authenticate the user, and based upon the information the identity provider brings back, you authorize that user to access certain parts of your application or certain data. Same thing works with Azure Active Directory. It's an identity provider and uses many of the same protocols as those other identity providers. So you go to Azure Active Directory and you say, authenticate this user for me. If they're authenticated, Azure Active Directory will bring claims back. And Azure Active Directory, as part of bringing those claims back, you trust it. And you say, okay, based upon these claims, you're authorized to access A, B, C, and D in my application. So it's that authentication authorization split that you see in modern web applications. Just implement it with AD for you, so that your IT pros don't have to go out and implement a custom identity provider. All they have to do is sync the identities from an existing AD box into Azure Active Directory, and you as a developer can consume these identities using ASP.NET Identity, using any of these other identity libraries you have, and implement that authentication authorization scheme that you've always wanted to implement anyways, but you didn't want to actually go and harass anybody about it. Now you can. So now we talked about Azure Active Directory from an authentication versus authorization standpoint. I do want to talk a little bit about virtual networks. Now, as a developer, you don't have to go too deep into virtual networks, but you do have to understand that the whole idea behind virtual networks is it gives you access to private resources from the cloud, gives you access to cloud resources from a private network. You can VPN directly from on-premise to Azure. You can make a site-to-site connection. You can VPN individually from individual computers. You can connect multiple private networks. You can connect multiple public networks. You can connect networks in the cloud. Maybe you have two VNets in the cloud. You can connect them together. All of this is done with VPN devices or software gateways. The idea here is it just allows you to create connections so that resources can talk to each other in a simplified manner without having to send, without having to expose ports publicly for the whole anonymous internet. Now, all of this VPN traffic is still sent over the public internet. There are options to avoid that will, such as ExpressRoute, but the idea here is it's all just VPN connections. So if you're familiar with what a VPN connection is, you pretty much as a developer have the logical understandings of virtual network connectivity. Now, you can connect individual devices directly to a virtual network using point-to-site connections, or you can connect networks to each other using site-to-site connections. When you configure a virtual network, you can configure it when you're creating that virtual network. You can configure it using PowerShell when you're creating it or creating a portal. You create address spaces, subnets. You configure other options. You can optionally create gateways. A lot of things you can do as part of this VNet configuration. But what's really interesting as a developer is that this VNet configuration is available as an XML file. So once you get a virtual network designed to the way you want, and we're talking classic virtual networks here, you can go and just export the VNet config as an XML file and then import that VNet config when you create a new virtual network. That way you don't have to go through clicking everything again or running those PowerShell commands again. This VNet config file is basically an encapsulation, declaratively, of all of your VNet configuration settings. In version 2 infrastructure, this can all be done in ARM with JSON. But in classic virtual networks, the one that we'll see used with these cloud services and the virtual machines, you're going to be doing this VNet config using an XML file. One of the things, and this is one of my favorite services, storage is my number one. Service Bus comes in at number 3 or 4. It's really hard to compete with DocumentDB and search. But Service Bus is still one of my favorite services. And the idea behind Service Bus, it gives us connectivity between our different applications. So if we want to implement connectivity with queues, we can use Service Bus queues, and they're basically a queuing mechanism. They have different features than storage queues. They're not better or worse than storage queues, they're just different. That's a key thing to remember. A lot of people trip up and say, oh, Service Bus queues are always better than storage queues. So whenever somebody asks, hey, we have this business requirement, which one should we use? They'll always serve Service Bus queues, or if they're trying to save money, they'll say storage queues. That's not exactly it. They're just slightly different. Topics allows you to target messages. And the idea here is that you can create a topic and subscribers can subscribe to that topic. So you can publish a message, hello world, to the topic greetings. And anybody who subscribed to the topic greetings can actually consume this message. This is interesting because if you've ever done any type of XAML work, you probably heard of the event aggregation pattern. The idea here is that you can produce event messages without knowing anything about the subscribers, so you don't have to create a direct connection. It serves as a broker. So as a subscriber, I can subscribe or unsubscribe from the topic as much as I want. And the people who are producing the message don't know anything about it. They just produce a message and they trust that the topic will send this message to all the appropriate subscribers. Relay is another interesting one. Service Bus Relay allows you to create it's not as simple as a proxy, but basically a relay between existing WCF service and some type of client device. Now this is great because you can do this and get two big advantages. One is that you're basically creating another endpoint for clients to connect to. So if you have a line of business application that's used by many different corporations and you want to be able to update the backend service without disrupting the existing customers, you can point them at the Service Bus Relay. Now with the Service Bus Relay, it actually routes requests to your WCF service that's bound to it, and your WCF service handles these requests and, if appropriate, responds. Relays can handle two-way messages or one-way messages. The magic of relays is that your WCF service makes an outbound request to the relay. This means that your IT pros do not have to poke holes in the firewall. If people want to connect to your WCF service, they don't have to go in and allow anonymous requests through their firewall into your WCF service. Your WCF service makes an outbound request to the Service Bus Relay, and then the binding happens there. And messages are routed two ways between the relay and your WCF service. So you don't actually have to go and change your network configuration to use Service Bus Relay. And now you're able to expose WCF services that are on premise to applications anywhere without changing the configuration of your network. Really big deal. The last one you want to know about is our Service Bus Notification Hubs. Service Bus Notification Hubs implements push notification infrastructure for you. So essentially, if you've ever sent a push notification to a mobile device, you probably know how complicated that is. Push notifications are pretty mean to deal with. You got to create them for iOS or Android, which is JSON, or create them for Windows, which is XML. Then you got to know the schemas for each platform, and then you have to stand up infrastructure to set all of this up. It's really, really big pain. Notification Hubs does all this for you. So it'll handle registering the devices. It'll handle sending the right notification style to each device. And you can go even deeper. You can implement templates so messages look different across different platforms. You can implement tags so that devices are tagged and you can actually send messages to people who meet a certain tag expression. So you can actually target devices and send unique messages to each type of device. Maybe send messages to all users in the state of California in the US. Or iOS users will have this extra image in their notification, whereas Android users will see this image somewhere else, maybe at the bottom instead of the left. The idea here is that you can change the way notifications, all this happens, again, without having to stand up in the infrastructure because it's all managed for you. And as a developer, when you're ready to send a notification, all you do is connect to the notification hub using your key and say, send this notification message to this target group of users using this template. That's it. So it really takes a lot of the busy work out of using notifications with mobile devices. Now, from a monitoring point of view, you can monitor your network. You can use the portal. That's where most people end up monitoring it. But you could also use the REST API and PowerShell to get information about your network, to determine what's going on, get status information, and do some of the really basic monitoring things. But as a developer, most of your monitoring is going to happen in the portal. One of the other things I wanted to bring up before we go into our last sample question is I wanted to bring up caching. Now this is a really controversial thing to talk about, but for the certification exam, the objectives call out using the Azure Managed Cache and enrolled caching. Unfortunately, these services aren't recommended and you only use really with legacy applications or applications you may inherit. But as far as certification exam is concerned, they are brought up because at the time the certification exam was designed, they were used for a lot of applications. A lot of Azure applications were already out there using the managed cache and enrolled cache. The managed cache is based on App Fabric and is used as a caching mechanism across many different legacy applications. The enroll cache is used with cloud services. It allows you to basically take a worker role and dedicate it as a cache instance and use that as a shared cache between maybe your web role instances or your worker role instances. Moving forward, the cache you're going to want to use is the Redis cache. But the reason I warn you about this is because when you go to Azure.com and look up documentation, Azure Cache is basically the Redis cache. It's just an implementation of Redis, which is a key value-based NoSQL store. Key value base is really loose definition here because the key can be complex here. So you can get into semantics of what type of NoSQL store if you want. But the big thing here is that any documentation you see almost likely is going to be about Redis cache and not the other two. So you're going to want to definitely look at some of the existing training material that do talk about the other two. And be careful when you look at Azure.com documentation because it will say Azure cache and they're talking about the Redis cache. Let's look at our last sample question. So you're a developer for Fourth Coffee. That's our context. Our business problem is you need to create a new queue instance in existing namespace in your Azure subscription. So we want to check, see if it exists already. If it doesn't, we're going to create it. So what options should we select? And this is just another code completion question. So here, we're going to use Cloud Configuration Manager again to get our connection string. And then we're going to use Namespace Manager create from Cloud Connection String. So instead of creating a Cloud account from connection string, we're creating a Namespace Manager. And then the Namespace Manager has a nice little method called queueExists that allows us to test if a queue exists, returns a Boolean. And it has a method called createQueue. So it allows us to create queue if it doesn't exist. Pretty simple stuff. Notice that the top part of this is very similar to what we do with storage accounts. Now that we talked about at a high level some of the things you definitely want to know to be prepared and excel at this exam, I want to give you some additional study resources. One of the most useful resources is if you go to azure.microsoft.com, they have learning plans. They have learning plans for web apps, virtual machines, cloud services, and Service Bus. Learning plans are a combination of activities. There are activities and articles, and it's basically a diagram that you can actually walk through and work through these at your own pace. You can work through the diagram online, you can print it out. The idea here is that it's a path or a plan that you can use to learn about the service. I highly recommend the Azure.com learning plans, and definitely if you haven't checked them out before, they're pretty easy to follow. Microsoft Virtual Academy remains an excellent resource for our certification exam training. We already have an MVA session called Developing Microsoft Azure Solutions, which scope is much bigger than this quick session. So this session is about a fifth or sixth of the length of the Developing Microsoft Azure Solutions session. So if you feel like that went a little too deep and there are some things you want to bring up level a little bit, that session is perfect. There's also the Microsoft Azure Developer Camps. There's a Web Apps Jumpstart that talks about the new app service web apps. And finally, there's the Cloud Dev Camp, which is based upon a lot of the dev principles that we talked about here. And the scopes of those last three sessions will be a little bit wider than the exam, but there's nothing wrong with learning more, right? There's no such thing as learning too much. For even more resources, you can look at Microsoft official courseware, such as the 20532 course that aligns with the certification exam. There's a Microsoft Press book that you can look at that actually helps you prepare for this exam. There's even Microsoft official practice tests that you can use to practice taking this exam, and it'll give you practice questions that are really useful in helping you learn where you are and what else you need to study. Of course, Born to Learn remains an excellent resource if you want to prepare for exams. There's forums available when you can talk to other exam preparers, and there's even an exam prep wiki that gives you plenty of useful information. So to wrap up, we talked about web apps, virtual machines, cloud services, storage, and networking. Hopefully this session has helped you become better prepared to take the 7532 exam, and I look forward to seeing you post a line about your success in earning the Azure Development Specialist certification and talking about how great you are at Azure, and maybe we could work on a project together someday. Thank you.